Welcome to the debate. If you have walked down the supplement aisle of a health food store, a pharmacy, or, well, even a high-end grocery store in the last 5 years, you have seen it. It's inescapable.
Mm-hmm.
Tubs of white powder, sleek canisters, pills, liquid shots, all promising to be the fountain of youth in a scoop. We are talking, of course, about oral collagen.
It's a market generating billions of dollars and arguably even more buzz. The promise is, it's incredibly seductive. Simply drink this smoothie and you will erase your wrinkles, fix your aching knees, and restore your hair to its former glory. It sounds almost too easy.
Exactly. It feels like magic, which, usually sets off alarm bells. But here on The Debate, we do not really care about the marketing copy on the back of the tub or what an influencer says on social media. We care about the clinical data. Today, we are tackling a question that actually divides the medical community right down the middle. Do oral collagen supplements actually survive the harsh acid bath of our digestive system to deliver real benefits, or are consumers just buying very, very expensive protein powder?
It is the definition of a polarized topic. On one side, you have these enthusiastic anecdotes and a booming industry. On the other, you have a skeptical scientific establishment just asking for rigorous proof. And today, we are going to find out where the truth lies.
I'm ready if you are. To lay my cards on the table, I believe the science has fundamentally shifted. 10 years ago, I probably would have agreed with the skeptics. We used to think of collagen as just a protein source. But recent clinical data, and I mean significant meta-analyses, demonstrate that specific bioactive peptides are surviving digestion and delivering statistically significant benefits for skin hydration, elasticity, and even bone density. This isn't just food anymore. It's bordering on pharmacology.
And I'm going to have to pump the brakes on that enthusiasm. My read of the current landscape is that it's plagued by what I call the cocktail effect, severe methodological heterogeneity, which is really just a fancy way of saying the studies are all over the place, and frankly, some alarming safety concerns regarding heavy metals. I argue that while there might be a faint signal in the noise, the miracle claims are vastly overblown compared to the actual evidence.
Let's get into it then. I want to start by addressing the skepticism head-on, specifically regarding the biological mechanism. For a long time, the primary critique, and it's one I heard in med school, was that collagen is just a protein. Digestion breaks protein into single amino acids, therefore eating collagen is no different than eating a piece of chicken or a boiled egg.
Which is a biologically sound argument. Your stomach is a pit of hydrochloric acid. Its entire job is to destroy complex structures. So if you eat a complex protein, your body breaks it down into individual bricks, amino acids, and then uses them wherever they are needed. It doesn't, send skin bricks to the skin just because you want it to.
That was a sound argument until recent research really debunked it. We have to look at the study published in Biomedical Research. It's available on JStage. This is the smoking gun for me. They used a vascularly perfused rat intestine model.
Okay, hang on. Vascularly perfused rat intestine. We need to clarify that we aren't rats.
I know. Bear with me because the mechanism is conserved. This model allows scientists to track exactly what crosses the intestinal barrier into the bloodstream. Now, if the just protein theory were true, they would have found only free amino acids, the single bricks. But they didn't. They found collagen hydrolyzate being absorbed as di- and tripeptides, specifically ones containing hydroxyproline. They even found surprisingly large chains like pentadecapeptides.
Pentadecapeptides? That just means a chain of 15 amino acids, right?
Correct. That is a massive molecule to survive digestion, and this matters because these aren't just fuel. They act as signaling molecules.
Okay, explain the difference.
Okay, think of a construction site. Eating chicken provides the bricks, the raw materials. These specific collagen peptides, they're the foreman yelling at the crew to start building. They enter circulation, reach the tissues, and trigger anabolic or, building processes. The pharmacokinetic data shows these specific messengers in the blood. You just can't dismiss that.
I'm not dismissing the presence of the peptides in the blood. I'm dismissing the leap of logic that follows. I'm sorry, but I just don't buy that the presence of a peptide automatically equals a clinical result, even if we accept the rat data. And again, rat digestion is not identical to human digestion. The Indian Journal of Dermatology explicitly notes that the link between these oligopeptides and the fibroblast receptors remains, quote, unclear.
Unclear usually just means we are working on mapping the exact pathway. Not that the pathway doesn't exist.
But in science, the burden of proof is on the claimant. It means we have a theory that they act as keys to unlock collagen production, but we haven't actually seen the key turn the lock in a human model. It is a hypothesis being presented as a fact. And what's more, you have to look at where this bioavailability data comes from. You have manufacturer studies, like the one from Sea Garden, claiming marine collagen is absorbed 1.5 times more efficiently due to particle size. But that's industry-funded data.
Well, science costs money. Industry funding doesn't automatically invalidate results, provided the methodology is sound.
No, but it should make us incredibly skeptical. When the people telling you this powder absorbs perfectly are the same ones selling the powder, you have to check your wallet. We are seeing a halo effect where we want it to work, so we accept weaker evidence or, manufacture claims that haven't been independently verified.
I see your skepticism, but let's look at the clinical outcomes that align with that bioavailability. If the peptides are getting in, which the blood data suggests, we should see changes in the skin, and we do. Let's look at the meta-analysis published in the Indian Journal of Dermatology by Dinesa and colleagues. They analyzed randomized controlled trials and found that collagen supplements were statistically effective in increasing skin hydration with a standardized mean difference of 1.25.
And for our listeners, what does a 1.25 mean in the real world?
In clinical statistics, anything over 0.8 is considered a large effect size, so 1.25 is enormous. For elasticity, the difference was 0.61. This wasn't a rounding error or some statistical fluke.
I'm not disputing that the numbers exist on the page. I'm disputing what caused them. And this brings me to my biggest issue with the skin research, the cocktail effect.
You mean the blends?
Exactly. Harvard Health has rightly flagged this. A massive issue with these meta-analyses is that many of the included studies use supplements that are not just collagen. They are often packed with vitamin C, antioxidants, CoQ10, and hyaluronic acid.
Because those things support collagen synthesis.
Right, but we already know, provably beyond a shadow of a doubt, that vitamin C and hyaluronic acid improve skin health. So, if you give a patient a collagen supplement that is actually a multivitamin with some protein in it and their skin improves, was it the collagen or was it the vitamin C and hyaluronic acid that we already know work? It's like drinking a vodka and orange juice and saying the vodka gave you the vitamin C. It makes it nearly impossible to isolate collagen as the actual cause.
That is a valid critique for the proprietary blends. I'll grant you that. Confounds are annoying. But not every study uses a cocktail. The Sea Garden study, which focused just on marine collagen, showed a 34.77% improvement in facial skin moisture after just 8 weeks. That is a very specific number and a massive physiological change.
Again, industry funded.
But peer-reviewed. Imagine a 35% improvement in your skin's ability to hold water. I mean, that is the difference between dry, flaky winter skin and healthy skin. And it tracks with other data. Momentous outlines a timeline based on the literature where hydration benefits appear in weeks 1 through 4, while wrinkle reduction takes 3 months or more. This consistency across studies, from Yuan et al. To Asiran et al., suggests we are seeing a real physiological timeline. The peptides increase hyaluronic acid production, which holds water. It is a very logical, consistent biological cascade.
Consistent is a strong word. I'll give you the hydration point. There seems to be a signal there. But again, have you considered the alternative explanation offered by orthopedic reviews? They found that self-reported outcomes were consistently more positive than objective ones.
You're talking about the placebo effect again?
It's powerful. When you ask someone, does your skin feel better after they have spent $50 on a fancy tub of peptides, they want to say yes. It's confirmation bias. And about the mechanism, If the supplement works by increasing hyaluronic acid, why not just take hyaluronic acid? Or better yet, listen to Harvard Health. If your goal is texture and elasticity, topical retinoids and sun protection have far superior long-term evidence than oral collagen. We have decades of proof for Retin-A. Why gamble on a maybe pill when we have proven topical solutions?
Because for many, topical treatments don't address the systemic issues. And this is where I think the strongest case for collagen actually lies. We focus so much on beauty, but the medical case for bones and joints is where this becomes revolutionary. This is where the signaling molecule theory really holds water.
I'm listening. But I have some data on joints that might burst that bubble.
Let me present the case first. We need to look at high-quality, specific studies, not just general surveys. There is a pivotal study by Koenig and colleagues published in PMC regarding postmenopausal women. This is a demographic at high risk for osteoporosis, for brittle bones. They didn't just ask, how do you feel? They administered 5 grams of specific collagen peptides, SCP, daily for 12 months and measured bone mineral density, BMD, via scans.
And the results?
The collagen group saw a significant increase in bone mineral density in the spine and the femoral neck.
And the placebo group?
The placebo group saw a decrease, which is expected with age. You lose bone as you get older. But here's the kicker. They analyzed bone markers in the blood. PM1NP, a marker for bone formation, increased in the collagen group. Meanwhile, CTX1, a marker for bone degradation, actually increased in the placebo group.
Let's break that down a bit.
Okay, think of your bones as a building that is constantly being renovated. You have a demolition crew, that's degradation, and a construction crew, that's formation. In the placebo group, the demolition crew was winning. In the collagen group, the supplement literally shifted the metabolic balance to the construction crew. It stopped bone loss and started bone creation. That is profound.
That is an interesting point. And the Koenig study is certainly one of the stronger papers because it used objective scans. However, I would frame it differently. It stands somewhat alone against a backdrop of inconsistency. The Orthopedic Review's systematic review found that generally, bone and joint health studies had significant methodological limitations that prevent definitive conclusions.
What specifically did they find?
Well, they used a metric called the positive outcome rate. When they looked at joint studies, they found a rate of 0.49. That means less than half of the outcomes measured showed any significant improvement. Is literally a coin toss. If I sold you a headache pill and said, look, this works 49% of the time, you wouldn't buy it.
But that review lumped together all sorts of different types of collagen and study designs. You can't just ignore a positive result because other studies were poorly designed.
No, but you have to be able to replicate it. And if we look at the broader orthopedic picture, like muscle recovery, the results are all over the map. Often the benefits are only seen if the subject is also doing resistance training. We know lifting weights builds bone and muscle anyway. So are we seeing the collagen, or are we just seeing the gym?
It's likely synergistic, but let's look at another mechanism, specifically for osteoarthritis. We aren't just talking about building mass, we are talking about immune modulation. There's a mechanism called oral tolerance, used with unnatured type 2 collagen, often called UC2.
Hold on. We need to distinguish this. This is different from the hydrolyzed peptides we were just talking about?
Completely different. Hydrolyzed collagen, the stuff in the big tubs, is chopped up into tiny bits to be absorbed. UC2 is the whole, raw protein helix. You take a tiny dose, just 40 milligrams. It's too small to build tissue. Instead, as described in PubMed, it interacts with the gut-associated lymphoid tissue, which is basically the immune system headquarters in your stomach.
So it's acting like an allergy shot?
Exactly. It retrains the immune system to stop attacking the collagen in your own joints. It reduces inflammation in the knee, not by building cartilage, but by calling off the immune attack. That is a sophisticated immunological pathway. It's not just eating protein.
That is a fascinating mechanism. I grant you that. The oral tolerance pathway is biologically plausible and very distinct from the building block theory. But we have to zoom out and look at the risk-to-reward ratio. You mentioned the momentous guidelines suggesting athletes or those with joint issues take 10 to 20 grams of the hydrolyzed stuff daily for years to see these benefits.
Correct. For maximal efficacy, especially for tissue repair, you need the higher doses.
Now bring back the Organic Consumers Association data. This is where I have a major ethical problem with recommending this stuff to people. They did a study of top-selling collagen products. They found that 37% of collagen products had measurable levels of lead, and 64% had arsenic.
Those are scary words.
They should be. If you are taking 20 grams a day, that's a huge scoop every single day for years for your bone health. You are voluntarily ingesting a cumulative load of heavy metals. Arsenic is a carcinogen. Lead causes permanent organ and brain damage. If the benefit for joints is a maybe, remember that 0.49 positive outcome rate, and the risk is arsenic poisoning, that is a terrible medical trade-off.
I see why that data is alarming, and I'm glad you brought it up. But measurable levels does not always equate to toxicity. We live in a world where trace elements are in everything from our rice to our water.
But this is a concentrated dose derived from animal parts that are known to accumulate toxins.
Which is why sourcing matters. High-quality hydrolyzed collagen from reputable sources, like the bovine or marine sources mentioned in the top-tier literature, can and is screened for purity. We shouldn't throw out a viable therapeutic tool because of poor quality control in the cheap, bargain bin end of the market. You don't stop eating fish because some fish have mercury. You source better fish.
But the consumer doesn't know which is which. That is the problem. The label doesn't say, now with more arsenic. It says, pure, natural, grass-fed. Without strict regulation, the consumer is flying blind. They are trusting a brand, not a regulator.
That is a fair warning of consumer diligence. You have to look for third-party testing. But let's bring this to a conclusion. Despite the heterogeneity in the data and quality control issues, I firmly believe the weight of evidence supports the efficacy of collagen. We have significant BMD increases in postmenopausal women, a group that desperately needs non-pharmaceutical options. We have measurable absorption of pentadecapeptides in the bloodstream. We have a clear mechanism where these peptides act as signaling molecules.
And the skin benefits?
The hydration data is consistent across multiple studies. Dismissing all this as just digestion ignores the sophisticated biochemistry at play here. High-quality, hydrolyzed collagen is a viable therapeutic tool for skin and orthopedic health.
And I maintain that while there is an interesting signal, particularly for hydration and perhaps that specific immunological pathway for osteoarthritis, the noise in the data is deafening. The cocktail effect confounds too many skin studies to be sure it's the collagen working.
But the signal is there.
A signal isn't a cure, and the safety risks regarding heavy metals are not trivial when we talk about daily high-dose supplementation for years. The science is promising, but it is not proven enough to justify the massive hype. Consumers would be better served focusing on established treatments like retinoids for skin and standard physical therapy for joints before relying on a supplement.
Thank you all for joining us on this exploration of the data behind the hype. We hope this helps you make a more informed decision about what you put in your body.
And remember, in the world of supplements, details like sourcing and formulation matter more than the headline. Until next time.